Bismillahirrahmanirrahim and Assalamu alaikum, my dear students. I welcome you all to the online session of electric circuit analysis. Before this, we have been studying chapter 1, chapter 2 and then chapter 3 of electric circuit analysis. From this section, that is after sessional 1, I'll be continuing to chapter number 4, which is related to the different properties, principles and theorems that are applied to various electric circuits. With this, I'll start my lecture. The first thing that we'll be studying is the linearity principle or linearity property. It is the property of an element describing, showing a linear relationship between the cause and effect. This property for resistor is studied only in this course. However, onwards, further this is applicable to other circuit elements as well, but at this stage we'll just study it for resistors in our circuit. As by Ohm's law, you know that V is equal to IR, that is voltage is equal to the product of current and the resistor in a circuit. Now, according to linearity property, if the current, which is directly proportional to the voltage in this equation, is increased by a factor K, then the output voltage is also increased by the same factor K. That is, if I increase K times, then the voltage, which is the product of current and resistance, will also be increased by the same scaling factor K. So in short, we can say that KIR is equivalent to KV. Therefore, a linear circuit is a circuit whose output is related, or we can say directly proportional to the input. Generally, a linear circuit comprises only of linear elements. That linear elements are sources. The sources can be dependent sources, they can be independent sources, as we have been studying previously. To have a clear understanding of this topic, I'll give you an example. We have a linear circuit which is powered by a voltage source Vs, and we have a load resistor, that is R. Current I flows through the load resistor R. Now, by linearity property, if let's say the applied voltage is 10 volt, it will yield a current of 2 ampere across the load resistance, considering that let's say the resistance value is 5 ohm. Now, if we reduce the voltage, applied voltage 10 units, that is from 10 volt to 1 volt, then by linearity property, this current that flows across the load resistance should also reduce by 10 times. So 2 ampere divided by 10, the current through the load resistance will be 0.2 ampere. So the scaling factor by which it was altered is 1 over 10. Now further, we'll consider another example in which we'll increase the scale, the input by 5 times, that is from Vs 10 volt to Vs is equal to 50 volts. So this means the current, which was previously 2 ampere, should also increase 5 times. So 2 cross 5 is 10 ampere. So the scaling factor over here is K is equal to 5. This is how it is shown that when we linearly increase the input, the output also increases linearly. To have a further understanding of this topic, I would like you to consider practice problem 4.1. Here we are given a circuit which comprises of 3 resistors, 4 ohm, 12 ohm and 8 ohm, and this series parallel combination is powered by a current source, that is Is. We are to find V0, which is the voltage across the 8 ohm resistance at 2 different values. When the current, input current is 30 amperes, and when it is increased from 30 to 45 amperes, what will be the impact on V0? So in both the cases, we have to find the V0, which is the output voltage across the 8 ohm. So we can see that we have a series parallel combination on the right hand side of our notes, and this is the circuit we are given. So the 3 resistors, we can see that 4 ohm, 12 ohm are powered by the current source Is, and V0 appears as across 8 ohm, just I told you. So since we have a series parallel combination over here, the current does not remain to be the same. So this means the entering current is divided into 2 parts. One part goes through the 4 ohm resistor, and the other part of the current goes through the 12 ohm and 8 ohm resistance portion. So in this case, this means the current is being divided. The current is divided between the 4 ohm and then the 8 and the 12. So we have to use the current divider rule to find out the value of current that flows through the 8 and 12 ohm resistance. So by current divider rule, you know that we put the opposite resistance value in the numerator and sum of all the resistor in the denominator and multiplied by the applied source. When I plug in all the values, I get is the output current across 8 and 12 ohm resistors is 1 by 6 of the applied current source. So we have the scaling factor is found. So what we do is we have to find the voltage across the 8 ohm resistor by voltage. By Ohm's law, we know that V is equal to IR. I is 1 by 6 of IS. When I insert the value, the scaling factor that I eventually get is 4 by 3 of IS. So this means the output voltage is linear related by 4 by 3, or we can say 1.75 times IS. So now we have to put in the values. First of all, we were given that IS should be considered as 30 ampere. When I put the 30 ampere current value, I get the output voltage that I get is 40 volt. Now in the next scenario, I insert the given value 45 ampere. By plugging in the 45 values and doing some basic mathematics, we get to know that now the output voltage is 60 volt. So the bottom line of this, or the conclusion of this topic, is that we have to find the scaling factor and then insert the values of the input, and the scaling factor is linearly related, that is directly proportional with some k factor. Once the k factor is found, we can easily find the output or the effect at different input or source values. Thank you. Jazakallah. The same topic will be repeated with another example in the next lecture to get a better understanding of this topic.